Welcome back to the official channel of Dr. Abdul Kalam Technical University. This is Anamika, Associate Professor, Kalkutia College of Engineering and Technology. In this class, we will solve some problem related to vector calculus. We already discussed this in previous lectures, in which we have seen all kind of operators, and in this session we will solve some problem to get more clear about all those operators. So let us start. Now first we have seen that there are four kind of operators, that is gradient, divergence and Laplacian curl. So all these operators are usually used to reveal interesting properties and interesting characteristic of any field. So let us start with gradient. Here is one scalar quantity is given. Always remember that gradient can be found only for the scalar quantity. Gradient of any vector quantity makes no sense. So the vector field V is given as e to the power minus z sin 2x cos hy, and as by seeing these parameters we can see that this scalar quantity is given in Cartesian coordinate, which is also known as rectangular coordinate. Basic parameter of Cartesian coordinate is x, y, z. As in this scalar function we can see x, y and z. It means that it is given in Cartesian coordinate. So we need to apply the value of formula of gradient in Cartesian coordinate. The formula of gradient in Cartesian coordinate are d. Here the scalar function is v, so we will apply dv by dx ax plus dv by dy ay plus dv by dz az. Now we need to take the differentiation of v with respect to x. So all other parameter except x will act as constant quantity. So here this term is having x, so apart from this term, that is e to the power minus z and cos hy, both will act as constant quantity. So it will be, means gradient is represented by this del v, simple product of del operator and scalar v. So now e to the power minus z and cos hy will act as constant quantity. However, we need to find the value of differentiation of sin 2x. The differentiation of sin 2x is nothing but the cos 2x, and further the differentiation of 2x will give the value 2. Unit vector will be ax plus, now we need to differentiate the scalar quantity b with respect to y. In this case all the quantities except y will act as a constant quantity. Here this term is having y, other than this these two terms will act as constant quantity. So this is e to the power minus z sin 2x. However, the differentiation of cos hy is nothing but the sin hy, and this will be multiplied with ay plus, now in the third term we need to differentiate this v, scalar v, with respect to z. So all the quantity except this will act as constant quantity. Here we are having sin 2x and cos hy, so we will write sin 2x and cos hy as it is because it acts as a constant, and the differentiation of e to the power minus z will be e to the power minus z only. However, for minus 1 here minus sign will come. Whole will be multiplied by the unit vector az. So this is the answer of gradient of scalar v, del v. We can simplify it and can write del v will be equal to 2 e to the power minus z cos hy cos 2x ax plus e to the power minus z sin 2x sin hy and minus, because here minus is there, minus plus minus minus sin 2x cos hy e to the power minus z multiplied by az. This will be multiplied by ay. This is the final answer of gradient of a vector v, where v is given in Cartesian coordinate. Cartesian coordinate is also known as rectangular coordinate. Now let us see, as we have 3 coordinates to learn. So this example is given in Cartesian cylindrical coordinate. How to find whether the function is given in cylindrical Cartesian or spherical? By seeing these quantities. We know that parameter of cylindrical quantities are rho phi z, rho phi z. In this function we can find rho, z and phi. One more important thing is that the cylindrical coordinate system is having one angle. So if there will be one angle, it means that the scalar or function is given in cylindrical quantity. If there will be 2 angle, it means that the function is given in spherical coordinate, because spherical coordinate, anything in spherical coordinate can be represented with the help of r theta phi, where theta and phi both are angle. So here in this we have to apply the formula of gradient in cylindrical coordinate, and in cylindrical coordinate the formula for del u will be du by d rho a rho plus du by d phi a phi plus du by dz az. One difference is that always need to remember that here the angle term will have one extra coefficient, that is 1 by rho. So we need to multiply du by d phi, that is angle differentiation, with extra coefficient, that is 1 by rho. Now let us apply this. So here is the function u. So first of all we need to differentiate this u with respect to rho. So all other things except rho will act as a constant. So we will write those first, that is a z cos 2 phi, which is acting as a constant. Now we need to differentiate rho square. The differentiation of rho square will be 2 rho. This is the coefficient we need to multiply with a rho here. Then again 1 by rho will appear as it is, and further we need to differentiate u with respect to phi. So all other quantities except phi will act as constant quantity. So we will write those quantity as it is, that is a rho square, and z will come as it is, and differentiation of cos 2 phi will be 2 sine 2 phi and minus sign will come. Again the unit vector will appear, that is a phi. Further, the differentiation of u with respect to z need to be performed, as we are going to differentiate this function, scalar function u with respect to z, so all other quantities except z will act as constant. So we will write those as it is, that is rho square cos 2 phi as it is, and differentiation of z will be 1, and the unit vector is a z. Let us simplify this a little bit. So this is a 2 rho z cos 2 phi a rho. This is the magnitude, this is the unit vector, plus here rho and this rho will cancel out and this minus sign will appear here. So we will replace this plus by minus. Rho z 2 rho z sine 2 phi a phi. Rho square cos 2 phi a z. So this is the answer of this question, where this is the magnitude and this is the direction. Here also this is the magnitude and this is the direction, this is the magnitude and this is the direction. Note here one thing is, note that gradient of any scalar produce a vector quantity, means initially this u were a scalar quantity. However, this del u means gradient of u is a vector quantity. Now let us solve this problem, which is given in spherical coordinate. As we previously discussed, that when there will be two kind of angle, it means that the function is given in spherical coordinate, because in spherical coordinate we are expressing any point or vector with the help of r, theta, phi, where r is the radius of the sphere, theta is the polar angle and phi is the azimuthal angle. Now here r is given, theta is given, phi is given, so we need to apply the gradient formula in spherical coordinate. The gradient formula in spherical coordinate, del w will be written as, expressed as dw by dr ar plus dw by d phi rho theta phi. So d theta a theta, here as theta is angle, so we need to multiply by a factor, that is 1 by r, again plus dw by d phi a phi. Here as phi in any spherical coordinate, suppose in any spherical coordinate, this is the spherical coordinate xyz, this is Cartesian coordinate in fact xyz, and we will make a sphere here. This is the sphere, where r is the radius of any sphere r, any sphere, and theta is the angle, polar angle, or you can say vertical angle also. Theta is the polar angle or vertical angle, and phi is the azimuthal angle or horizontal angle. So all the quantities are indicated here. Here you can see that theta is associated with r, that's why we have multiplied the theta term with 1 by r. However, phi is associated with rho, so we will multiply the phi term with rho, but as rho can be written as r sin theta, means we can write rho as r sin theta. If we will resolve r into this plane and horizontal plane, vertical and horizontal plane, it will be r cos theta. In z direction we can represent z equal to r cos theta. However, rho can be written as r sin theta. So in final formula we can replace rho with r sin theta. So let us solve this. So final formula of gradient will be del W is equal to dW by dr AR plus 1 by r dW by d theta A theta 1 by rho can be written as r sin theta dW by d phi A phi. Now to evaluate this, we need to differentiate this W term with respect to r. So all other quantity will keep as it is, will come here as it is, sin square theta cos phi. The differentiation of r will be 1, so it will be 1. Then we will write the unit vector AR plus 1 by r will come as it is. Then we need to differentiate this W term with respect to theta. So except theta, everything will come as it is, that is 10 r cos phi. Now here is the sin square theta. So differentiation of sin square theta will be 2 sin theta, and differentiation of sin theta will be cos theta. So finally we can write it as cos theta. This will be multiplied by a unit vector theta A theta plus, in the third term we need to differentiate this W term with respect to phi. So all other quantities except phi will be act as a constant and will come as it is here, but before that we need to write this coefficient also. So this is 1 by r sin theta. After that we will write 10 r sin square theta, and differentiation of cos theta will be minus, differentiation of cos phi will be minus sin phi. Now we can cancel this theta by this square, and here the unit vector of A phi will appear. So after simplifying, already it is simplified. So this is the answer for gradient of a scalar. We can write it as 10 sin square theta cos phi AR plus r and r will cancel out, then it will be 22 multiplied by 10, 20 sin theta cos theta and cos phi a theta plus will replaced by this plus will be replaced by minus, because here is the minus 10, r will also cancel out, 10 sin theta sin phi, and unit vector this a phi will appear here. So this is the answer for this question. Now we will solve some problem based on divergence of a vector. Divergence of any vector gives the idea about how much a vector field is diverges, whether it diverges or converges or moving parallelly. So here we can see that the vector is given p is equal to x square y z ax plus x z az. As x y z is given here, it shows that it is given in Cartesian coordinate. So we need to apply the formula for Cartesian coordinate only. The formula for divergence in Cartesian coordinate will appear as this, means we need to differentiate every coefficient with the corresponding component. One more important point here, p is a vector quantity because in this we are having both magnitude as well as the direction. This part is magnitude, however this ax shows the direction along x-axis. Here also this is the coefficient or magnitude of the vector p, however az shows the direction. So divergence can be applicable only on the vector quantity. Divergence of any scalar quantity makes no sense. So remember it. And finally, divergence maps a vector into scalar, because our final result will be scalar. So let us solve it. So this is the ax, this is the px, actually x component, and this is the pz. This formula is given for some vector a. Similarly we can write the formula for p vector also. So del dot p, divergence can be represented as the dot product of del and the vector p. So del dot p will be equal to dy dx of px plus del y of py plus del y del z of pz. Now here px and pz is given, however py is not given. It means that py is 0. So accordingly we will solve the problem. Dy dx of px is how much? X square y z plus dy of py is not given, that is a 0, then plus dy dz of pz is given. So dy dz of pz is given how much? xz. After solving this we will get 2 x y z. because it is differential because all the quantities except x will act as a constant quantity. So, we have written y and z as it is. However, x square, the differentiation of x square will be 2x plus this term is 0, and for this we need to write x as it is, and for z the differentiation with respect to z will be 1. So, this is the final answer of this question. Now, let us see this problem. Here we need to find the divergence of vector q, as we have seen that for anything, here we are having one angle, this phi. It means that the function is given in cylindrical coordinate, because in cylindrical coordinate we are having one angle term and two position length term, distance term. So, to solve this problem or to find the divergence of this vector q, we need to apply the divergence formula used for cylindrical coordinate. In cylindrical coordinate, for any vector A, the divergence can be found using this formula. Accordingly, we can solve this problem as del dot q will be equal to 1 by rho d by d rho rho a rho plus 1 by rho d a phi in place of a we will write q here, q, and here also q, d phi. Similarly, here will be d qz by dz. This term is the q rho, this term will be q phi, and this term will be qz. So, 1 by rho differentiation of rho will be as it is, differentiation of this q rho term means d by d rho rho multiplied by, after multiplying this q rho term, it will be square, because here also we are having one rho term. So, rho square sin phi a, sorry, sin phi. Further, we will write 1 by rho as it is. Now, q phi term is rho square z, so we will write here d by d phi rho square z plus this term will be written as d by dz. Qz is this much, that is z cos phi. Now we need to simplify this, and after simplifying this it will give as one by rho 2 rho sin phi. Rho will cancel out, plus here as no phi term is there, so the differentiation of this term will be 0, and finally 1 by rho multiplied by 0 will be 0. Now here we can see that differentiation of z cos phi will appear as it is, and differentiation of z term will be 1. So, the final answer is 1 by q, sorry, the final answer is 2 sin phi plus cos phi. This is the final answer of this problem. So, in this way we can solve other problem also, as for example, this is the function, vector function given in spherical coordinate, because here we can see that there are two kind of angle, that is phi and theta. It means it shows that the function is given in spherical coordinate, and for spherical coordinate the formula for divergence is given like this. So we need to apply this formula to solve such kind of problem. So for this problem are just for the practice, you can practice at your home. In the next class we will see Laplacian as well as the curl, and we will solve some problem on that also. So in today's class we have studied various problems based on divergence as well as gradient. Gradient transforms any scalar quantity into a vector quantity. However, divergence transforms any vector quantity into scalar quantity. Both are reverse to each other, and further divergence shows whether the field diverges or not. If the value of divergence will be positive, it means that the field is diverges, means it is spreading out. If the value of divergence is negative, it means that the field is converges at some point. Or if the divergence is 0, it means that the field does not diverges, neither diverges or nor converges. It means that field is moving parallelly. This is all about the concept of gradient and divergence. Hope you would have understood it well. So thank you for the class. Hope you will be safe and fine in this pandemic. Thank you so much.